क्लासेस थोड़ी सी कम थी, लाइव सेशन ज़्यादा चल रहे थे, so I'm a bit out of practice, like a bit. It may take 1 or 2 days that I can be doing it again very fastly. So, okay, the first thing, beta, what is the average human weight? Any one of you? Anyone? What is the average human weight?
So 75 kg.
65.
65, 70. Okay. When we standardly talk about an adult human weight is 70 kg. And we take it for a male. It's nothing about anti-feminism, but it is usually taken of males. Okay? Females are usually not of 70 kg until and unless they get married and get 5 kids. Okay. And what is the percentage of water in an adult body? Anyone?
60 to 80%.
Yeah, 65% on a standard value, 60%. And if we just take the 60%, the total water in a human body is 42 liters. So an adult human body has 70 kg weight and it is 42 liters of water. So just a question. If you just see that a thing weighs 70 kg and it has 42 liters of water, how should it feel like or look like? Anyone? Should it be looking like a pile of mud or slime or a paste? जैसे देखें आप 70 किलो आटे में एक 70 kg आटे की डो है, फ्लोर डो है, उसमें 42 liters water है. It should be like thin, watery. Should it be? बोलो यार, it's nothing to be shy about. What should be its appearance? बड़े यार खामोश लोग. It should be looking something like slimy, thin, slimy, yes. But what are we? We have a single pore of the finger, lines, and the nose, the earlobe, the skin, the texture, everything is very well defined. So, definitely, this water is not present haphazardly. This water is divided into two major compartments of the body. What do we say then? See, wait. What? What are the two compartments? Anyone? Intracellular and
Intracellular.
extracellular, yes. So intracellular and extracellular. But extracellular here, it is again divided into two. Can anyone tell me?
Interstitial.
Very good, Farooq, Shabash.
Interstitial and vascular.
Very good. Shabash, Farooq. कहाँ पढ़ा बेटा आपने? Where did you study it?
हामिद साहब ने बताया था.
Very good. Allah Hamid साहब को सेहत जिंदगी दे. He's a beautiful person and a good friend of mine as well. मजाक में तो हम किसी को छेड़ लेते हैं, but he's a beautiful person from inside. Okay, extracellular, very good. एक जगह है interstitium and just ignore the spelling mistakes if yes you get one. It can be just a slip of typing. Okay? Interstitium, and the second one is आप इसका स्क्रीनशॉट ले सकते हैं आखिर में. Do not worry to write. ठीक है? Just understand. You can just take a screenshot of it afterwards. Interstitium and intravascular. By default, interstitium is the space which is between the cells. तो इसको हम एक और नाम देते हैं intercellular. We can just say it intercellular. While intravascular is in the blood vessels, and this is obviously plasma. So these are the two names which can be used interchangeably whenever a text is in front of you, or a book or a note or anything. Okay? So this is the other names. Up, the question arises here is what is the distribution? What is the distribution of these waters in the various body cavities? यार मेरा लड़का बहुत आइटम है यार यार बहुत शोर करता है मैं तुम्हें तुम्हें दिखाऊं मैं शोर किया उसने बाहर से उसको टेंशन हो रही पापा अंदर बैठे हैं तो बैठे क्यों है दुआ 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 बेटे अजान को भेजना इंट्रासेलुलर इज इतनी देर में आता है तो 2/3 2/3 और अजान को भेजें जरा एंड एक्स्ट्रा सेलुलर इज 1/3 मासी अजान को भेजें अब इसमें से भी जो इंटरस्टिशियम है इस 1/3 में से 3/4 है और इंट्रावास्कुलर जो है वो 1/4 है so this is the distribution और अगर हम इसको just take it into liters so the 2/3 of 42 is 28 liters और आपसे कोई पूछे कि बॉडी का मेजर वाटर कहाँ पड़ा है आपके फौरन दिमाग में ब्लड आता है हाँ? If someone asks you where is the majority of water of the body present, you will just think about blood. But just look here, the blood is very limited as compared to the whole body water. So extracellular is 14 liters. And out of this 14 liters, 11.5, no, 10.5, sorry. 10.5 liters is in the interstitium. However, remaining 3.5 liters is in the plasma. Now another thing comes to our mind that how is it possible that these waters are separated? And yes, they are. Because in this scenario, for 42 liters and 70 kg, it would be a very messy sort of a mixture. So definitely Allah subhanahu wa ta'ala has placed a few membranes here which are separating these compartments. Now will love to know your knowledge. What should be the names of these membranes? Any one of you. Anyone. What should be these membranes? Can anyone tell me? Hmm? No one. Like seriously? What is the outer covering of a cell?
Cell membranes.
Yeah. The outer covering of a cell is cell membrane. So this yellow line which is on this left side should be the cell membrane, right? Should it be?
सर ये और ग्रीन कलर विजिबल नहीं है इसको थोड़ा चेंज करने का
As large who color blind. Okay, we'll just use another color. So this membrane is the cell membrane and this membrane should be, what should this membrane be? It is the capillary membrane. I'm not talking about the vessel wall as a whole, only about the capillary. Why only the capillary? Because, can anyone tell me why am I just talking about the capillary membrane, not about the cell membrane as a whole? Not about the vessel wall as a whole? Because the exchange of substances occurs. Yeah, very good. The exchange occurs only in the capillaries. So we will not talk about arterial wall and venous walls. So now there are three things here. Three things which can pass through these membranes. Can, not do. Which do pass is another topic. But which can potentially pass are three things which you should know every time. Number one is water. Number two are ions. And number three are proteins. And ions, to be on the safer edge, I'll just say majorly sodium. because the major cation of the extracellular compartment is sodium, and it is the ion which is making the osmotic pressure of our body. Okay, so इधर भी हम तीन चीजों का नाम लिखते हैं. Here also comes water, ions, and proteins. Now, a few things from here can just pass through this membrane, few cannot. Okay. Can any one of you tell me, is water freely permeable through the capillary membrane here? If we are just talking about this thing here, is water freely permeable through the capillary membrane? I just need answers. You should just tell me. I've told you it's nothing obnoxious, nothing to be shy about. Okay, someone has said yes, I guess. Okay, you guess yes. Anyone else? You do not even have
Yes,
the
sir.
liberty. Yes, yes, okay, yes. So water is freely permeable. We just put a tick here. Ions. What do you say? Yes, water does. Yeah, very good. So what about ions? No. Okay. No. Zameen says no. Be fast. We will be a bit slow in the first 2 to 3 days. No, yes, no, yes, no, no, yes. It's passing through it. It's a yes. It's a yes. I'll tell you how. Yeah, very good. No depends upon the concentration difference. Very good. This is someone. Who is it? Amal Fatma. Excellent. And what about proteins? G. Anyone? What about proteins passing through the capillary membrane? No, no, no. Can you tell me why no? Because if the proteins are lost in the interstitium, only low molecular weight, yeah, can pass. If the proteins are lost in the interstitium, they have to be carried back through to the blood through the lymph. So proteins do not. I'm asking about freely permeable. So proteins do not pass. Now we just come on this side between the cell membrane and the extracellular space. Cell and the extracellular space. Does water pass? Yes, okay. Do ions pass?
Yes, sir.
Yes, yes, yes. Zarmeen says yes. Dot, 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 dot says yes. By channels, yes. I'm asking about freely permeable. No, it's a big no. Why? If if ions were freely permeable through the cell membrane, the concentration of sodium outside the cell was 142 milliequivalents per liter. It should have been 142 inside. If potassium was 140 inside the cell, it should have been 140 outside. But it's 4 outside. Potassium is 4 outside. Sodium is 14 inside. You remember it? So ions are not freely permeable. Ions cannot pass through the cell membrane. अगर ion cell membrane को pass करते, यकीन करें, our life would have not existed. And proteins, okay. Now, what about the proteins? No. Proteins are a big no. Yes, very good. Now, यहाँ तक समझने के बाद यहाँ तक बेटा बात समझने के बाद let me tell you one thing. Look, in our body, water is not having enough liberty. Water is not, free to move. If water would have been free to move, our body would have become a mess. Okay. So what is the theme? The basic theme in our body is that water can only move where ions can move. And to be very specific, ion, if I say ions, it is sodium. What is it? Sodium. And the have you ever sweated? आपको पसीना आया? Have you ever cried? आपको आंसू आए? If just by mistake a sweat or a tear just goes into your mouth, what's the taste?
Salty.
Why is it salty?
Presence of sodium.
Because that water is moved outside from the body by a movement of sodium. Remember one word of mine, one sentence I may say. If sodium is Juliet, water is Romeo. सुनिए कहानी हीर रांझा वाली, अगर सोडियम हीर है ना तो वाटर रांझा, वो जिधर उसने जाना है, wherever sodium goes, water will come after it. Exceptions do exist. There are two exceptions in the body. One is ADH, which you have not studied by far. It is in second year. And there is one thing else that we can just ingest water without requiring sodium. However, in the movement, if the kidneys want to increase the urine output, they just excrete out sodium. Water moves out. If the kidneys say that we do not want to lose the water of the body, they preserve sodium of the body, water remains in. So sodium, the water will go everywhere where sodium goes. So, and the next thing, the pressure which a solution of sodium and water makes is known as osmotic pressure. What is it known as? Osmotic pressure. And that osmotic pressure is normally in our body measured in milliosmoles per liter. Do you know the value? Anyone? Google ही कर लो. It is approximately 290 milliosmoles per liter, but a range exists, usually 275 to 290 milliosmol per liter. And what is it in terms of quantity? In terms of quantity, it is 0.9% sodium chloride. Do you see this value familiar? This one, 0.9% sodium chloride. Yeah. Where have you studied it? Saline solution, yes, the normal saline. Why do we say it's normal? We say it normal because it is according to the normal concentration. It is the isotonic solution. Very good. Now, let me tell you one thing else. There is another superior thing to sodium, and its name is protein. When we make a solution of ions, it is known as a crystallite solution. You can just make notes of some things. Everything may not be possible. It will not be possible for me to write here. If we mix a solution of ions in water, it is known as a crystalloid solution. And the pressure that solution bears is known as osmotic pressure. And the normal osmotic pressure of our body is made by a solution in which 0.9 grams of sodium are dissolved in 100 ml of water, weight by volume solution. You remember in FSC you have studied. And the pressure generated is approximately 280 to 285 to 90 milliosmol per liter. It can vary, obviously. It is variable, so it is always mentioned in a range. Okay. Is it clear up till now?
Sir, एक दफा repeat कर.
The normal osmotic pressure in our body is made by sodium. And the solution is 0.9% sodium chloride, because the major anion in the extracellular fluid is chloride, the major cation is sodium, and this sodium is actually holding the water. If आपने सुना है कभी, why does the doctor says to you elderly who have hypertension that not to ingest sodium in larger quantities? आप नमक ना खाएं, do not use salt in like large quantities to a hypertensive patient. Why? Have you ever thought about it? Because the more amount of sodium I'm gonna ingest, my blood will have more sodium and it will gonna pull more water through osmosis, and my blood volume will increase obviously, and my blood pressure will rise, which will not be good for me. Yes, very good. So, and in medicine, we give a few drugs to reduce the blood volume. They are known as diuretics, and what they do, they excrete the sodium from the blood through the kidneys. What happens is that the water just moves after it, and the water is lost as well. The blood volume falls, and the patient becomes normotensive, or the blood pressure declines. Is it clear? So after sodium, after talking about sodium, we'll talk about another thing, which is amino acids, or you can just say proteins. A solution made up of proteins is known as colloidal solution. The solution made up of ions was known as, tell me, was a crystalloid, and a solution in which proteins and water is there, like water is the solvent and the solute is proteins, that solution will be known as a colloidal solution. And now you all know, you have studied biochemistry for second chapter of proteins. You know there are plasma albumins, plasma globulins. You may have studied the classification as well. Have you heard the names?
Yes, sir.
So इसका मतलब क्या है कि our body also has a lot of proteins. And for those proteins, the blood has another type of pressure which is known as oncotic pressure. Colloidal solution has a pressure which is known as oncotic pressure, and that oncotic pressure is due to the presence of proteins. Normal oncotic pressure, और इसको हम एक और नाम देते हैं plasma osmotic, colloidal osmotic pressure. Oncotic pressure is also named as colloid osmotic. Have you heard the name? I hope so. ये क्या हो गया? I hope so. These things would have been helpful. Normal colloid osmotic or oncotic pressure is, it is roughly taken 32 millimeters of mercury. It can just be high or low. Normally कितना है? Guide 10 के मुताबिक, according to Guide 10, it is 32 millimeters of mercury. Now, after all of this discussion, let me tell you one thing. There are three things here. There are three things here. One is proteins, one is ions, one is water. अब मेरी एक मिसाल समझिएगा. Water is like a student. Water is most abundant, and they're like students. Ions are like a teacher. They're less in number, but they can govern the water. And proteins, it is like the vice chancellor or the principal. It is very rare, it is less in quantity, but it can govern both of these. Did you get my point? Water की example क्या है? Water is like students, high in quantity, not जैसे अब if there have been no teacher in the classroom, what will you people do? You'll just scream like monkeys, है ना? ऊपर से नीचे को जा रहा है, को बाहर आ रहा है, को खेल रहा है, को सेल्फियां खेल रहा है, whatever, you will be mismanageable. So water is abundant and it cannot be governed without ions, which is a teacher for the time being at least. अल्लाह करे आप लोग इज्जत रखते हो हमारी. So for the ions is like a teacher, and if now take another scenario. There is a field trip. Your class is out on a trip, and the teacher is with you because he at that very moment is responsible for each of your activity, because he will be asked if someone is lost or damaged or gets anything bad with him or her. So the ions will have some limited liberty towards water. They will give very limited liberty. बेटा इधर जाना इधर नहीं जाना, इधर आप जा सकते हैं इधर नहीं जा सकते, इस वक्त आए इस वक्त ना आए. That's all. There will be clear instructions. So to be precise, what I want to tell you is that if the solution is purely of water, water can move anywhere. Water can move anywhere between all of these three spaces. If the solution is ion based, water will only have a liberty to move to a place where ions can go. Did you get my point? If the solution is purely of water, water will move throughout of all of these spaces because there will be no governance. If there are ions, the water will have a liberty only to move to that point where ions are allowed to go. Like if I am with you, I'll say कि यार यहाँ पे तो मैं भी नहीं जा सकता, तुम कैसे जाओगे? I'm not gonna go there, so you cannot go. That's all. Now when the vice chancellor comes, will you listen to me? It would be very unlikely because he is my teacher as well. हमें पढ़ाया हुआ उन्होंने. So I'll be saying just listen to him. He is my teacher as well. So आता हूँ बताता हूँ उसको भी बता. And when there is a solution which is made up of proteins, then water will move according to the liberty given by the proteins. The ions will be, उनको निकाल दिया जाएगा दरम्यान से. They will be just ignored. So if the solution is a colloidal solution, water will move only where the proteins will go. If the solution is based on ions, water will move only where the ions can go. And if the solution has both ions and proteins, water will move only where proteins will move because the superior most entity is the proteins. अगर proteins कहीं नहीं जा सकते, water cannot go there. Now just look here. There's a question. Can you just elaborate these compartments in single words? Look, this is a cell. For example, this is a cell. The fluid inside this cell is the intercellular water, intracellular space, which is 28 liters. It is water, okay? Every cell has to take its supply of oxygen and nutrients from the blood. Now, every cell does not has a direct access to the blood vessel. A blood vessel is lying here, for example. The space between the cell and the blood vessel is the interstitium. So blood vessel is here, then there is interstitium, then comes the cell. The first membrane which the fluid has to pass is the capillary membrane, and then through the interstitium it should pass the cell membrane to enter into the cell. Now did you get it? हाँ जी.
Yes, sir.
ओके. अब देखें ये सारी कहानी क्लियर हो गई. आई गेस इट्स obvious to everyone now. ठीक है. Now okay. And the line in between here is dividing the body. On the y-axis, we have osmolarity, which is increasing. On the y-axis, we have osmolarity. On the x-axis, we have volume, which is increasing in both directions. Okay? Okay? Can you understand it? Osmolarity. Just a second. थोड़ी सी सेटिंग करनी पड़ती है. I just told you that I'm using it like after quite a lot of time. मैं उम्मीद करता हूँ कि मैं जल्दी ही इसके ऊपर काबू कर लूँगा. To write on laptops in this age. एक तो आपकी उम्र है ना. Your age is very good. So in my age, it becomes a bit difficult to be a bit cyber. So there was actually a mistake in information. So we have got this thing here. Okay. The space here, it is the intracellular space, which is like more than 2-3%. What should this be? This is the extracellular compartment. ECC is extracellular compartments, ICC is intracellular compartment. So this 2/3 is represented here, while this 1/3 is represented here. The membrane here which we are talking about is this membrane, which is separating both of them, is the capillary membrane. Is the cell membrane. What is it? The cell membrane. ये जो membrane हमने बनाई है, ये कौन है?
Cell membrane.
Cell membrane. This is the intracellular compartment. This is the extracellular compartment. And extracellular compartment has obviously both. You know what? The interstitium as well as as the plasma. Okay. Now we have 3 types of solutions. The first type of solution is, what should we talk about? Isotonic. So the first solution we have is isotonic. Okay. And what is an isotonic solution by default? What do you know? Isotonic solution has another name which is normotonic. And this is a solution which is 0.9% of sodium chloride. Should it be like that? And we should know a few examples. अभी एक बच्ची ने बोला, the area where you can infuse this water, it's the plasma. Because you're gonna pass an IV line and you can just pour the water in here. So this extracellular space is the point where we can put the water. Clear? Okay. Now I'm gonna give isotonic solution in which point? Here. We are giving isotonic here. Okay, now what's gonna happen? Anyone? Can you tell me? What would happen to the volume of the extracellular space? Soche. Increase. Who is
Increase
it?
it, sir.
Very good. Yes. So we'll make the changes in black. We have made the normal thing in orange. So definitely what's going to happen here is the volume will increase of extracellular space.
Not effective.
Because the solution given has the same osmolarity as of the blood, the osmolarity will remain same. Now what will happen to the volume of intracellular subspace? Very good, shabash. This is why I love to teach students of a government medical college. Private
Remain same, sir.
Why? Who is it? Oppo F11, what's your name? I guess you have someone from there, Afghanistan. Who is it?
Faizullah.
Oh, okay. Oh. Why? Why Fazullah?
Sir, क्योंकि आप
When ions and proteins are not present. Because this solution has ions, as the ions can pass here, it will distribute equally in these two spaces. And as the ions cannot pass from this membrane into the cell, what's not going to go inside because ions are not going there. For example, I'm with you, I'm saying I'm not going to go in that space, in that place, you should not go also. That's all. So ions will not move. Sorry, the water will not move. Excellent. And now here we can just write the changes or the findings. It will increase extracellular volume. That is all. Nothing else gonna happen. Osmolarity of extracellular compartment, osmolarity and volume of intracellular compartment both will remain same. Everything will remain unchanged. Only extracellular volume will increase. So can we give these solutions in some sort of particle uses? Can we just think about it? Should there be some uses where we can give this sort of a solution? Fatma, I'll come there. Dehydration. For example, you are coming from scorching heat from outside, and you will just want to have a lot of water. And if it would have been like limu pani or squash or something with a bit salt and sugar, it would be like the best thing. Dehydration. If one gets profuse diarrhea, what is the solution you give? ORS. ORS is this. It has lactate, it has saline, it has sugar, it has sodium, it has chloride, it has potassium, that all of the losses of the body are fulfilled. So dehydration, swear, well, no, dehydration can be due to anything. Dehydration can be due to swear, diarrhea as well. Burns. In burns, the skin is lost and a lot of extracellular water is lost. So we can give there. And yes, blood loss, it's not a primary solution of choice, but yes, it can be given. So these are four main things which you can just remember for the time being. And vomiting as well, heat stroke, water loss. And when not to be given, contraindications. Can anyone tell me? When should it not be given? Oy Fatima, shabash. Why in hypertension? Why should not we give in high blood pressure? That the blood pressure will increase. And there is a situation which we say it as heart failure or cardiac failure. Heart failure or cardiac failure क्या होता है? When the heart is unable to pump adequate amount of blood to the body. If the heart is already failing, you should not overburden the heart. So the heart will fail further. Clear? Now, and in this solution, as the intracellular water does not change, intracellular compartment does not change, you have done a practical in which you just put a red blood cell in a normal, isotonic solution. There was no change in RBC. याद करें, there was no change in RBC size when it was put inside an isotonic solution. कैसा? Clear हो गया बेटे? Is it a bit informative or not? Now, okay, I'll just take 3 to 4 minutes break here. हम आगे चलते हैं, इसको कंटिन्यू करते हैं, 2 और सॉल्यूशंस को भी पूरा करते हैं. Just take a 2 to 3 minutes break. आप इसके ऊपर जरा देख लें. If you have any question,